Welcome to the next video of Machine Learning Practice course. In this video, we'll demonstrate a sklearn dataset API. There are three APIs. The first one is to load small datasets bundled with sklearn. They're called loaders and they start with prefix load underscore. Then we have fetchers that fetch larger datasets from internet and loads them in memory. They start with prefix fetch, and we have generators that generate controlled synthetic datasets and they start with generate or make underscore prefix. Loaders and fetchers return a bunch object, while generators return a tuple of feature matrix and label vector. Sometimes it also returns label matrix depending on the nature of the problem. Loaders and fetchers can also return a tuple of feature matrix and label vector if we set return underscore x underscore y argument to true. Let's first look at the loaders. So the plan here is to demonstrate loaders, then fetchers, and then generators. We won't be demonstrating all the loaders, we'll be demonstrating a couple of loaders and then we'll give a few of them as exercise for you to practice. So for example, this load diabetes and load digit, we will partially demonstrate these loaders, and some part will be left to you as an exercise. And these are guided exercises where we have given instructions and you are required to write maybe a one-line code based on the instructions provided in the exercise. We will follow the same pattern in fetchers as well as in generators. In generators, we will have make regression, make classification, make multi-label classification, and make blobs, which is used for generating synthetic data set for clustering. Okay, so let's get started with loaders. Let's first load the IRIS dataset and let us close this table of content so that we get more space on the screen. Okay. Let's load the IRIS dataset. So IRIS dataset is an important toy dataset that is used to demonstrate multi-class classification problem. IRIS dataset has 3 classes and there are 150 examples. Each example comes up with 4 features. So let's explore how to load this IRIS dataset using dataset loaders. So we have load underscore IRIS library that helps us, or load underscore IRIS API from sklearn.dataset library that helps us to load the IRIS dataset in memory. So we can call load underscore IRIS function and that returns a dataset which is a bunch object, and bunch is a dictionary like object with the following attribute. It has got data and target. At least these two attributes are present in the bunch object. Data has got the feature matrix, whereas target is the label vector. Then we have feature names and target names. They contain names of the features and classes respectively. We also have full description of dataset in DSCR key, and we have the path to the location of the data in the file name key of the bunch object. We can make sure that the type of the returned object is indeed bunch by invoking type on this data object, and you can see that it is indeed a bunch object. Now what we'll do is we will try to see what kind of features are present. Let's examine the content of the bunch object. The first one is names of the features, so we can simply write this command data.feature underscore names, and it returns 4 features of the IRIS dataset, which is sepal length, sepal width, petal length, and petal width. So we can see here the names of the features. Then we can also examine the names of the labels by calling target underscore names on the data object, and you can see that there are three different classes: Setosa, Versicolor, and Virginica. The next important thing is the feature matrix itself, and it can be accessed by looking at the data attribute of the bunch object. Let's look at first 5 examples in the feature matrix by invoking the data attribute of the bunch object and looking at first 5 examples. And you can see that there are 4 features per example here, right? So this is the first example with 4 features, second example with 4 features, and so on. Let's examine the shape of the feature matrix and by calling data.data.shape, and we can see that there are 150 examples, each with 4 features. Next, we will examine the label vector and its shape. The label vector can be invoked by calling the target attribute of the bunch object, and you can see these are 150 labels corresponding to 150 examples, and there are 50 examples from each of the classes. There are first 50 example belongs to class 0, next 50 example belongs to class 1, and the and then the remaining 50 examples belong to class 2. So we can read additional documentation on load iris dataset by putting a question mark before load underscore iris function, and you can see that there will be a documentation that will pop up here, and by reading this documentation you can understand various parameters and the return types of this particular function. This particular function also documents what is the dataset like. So you can see that there are 3 classes, 50 samples per class, the total 150 examples. Each example has 4 features, and the features are real positive number. So you can get more such information about the dataset as well as the functionality of the API by reading such documentation within your Colab notebook. Let us close this documentation and move forward. So this is how you can load and examine different datasets. So typical things to examine is feature matrix, then target labels, then look at the shapes of both feature matrix and labels to make sure that they have same number of examples. Then we can look at other things like the dataset description, and if we are interested in knowing more about the function itself or the loader itself, we can invoke its documentation. So we can also make these loaders to return tuples of feature matrix and label vector, and for that we have to set an argument which is return underscore x underscore y to true, and when we do that, the load iris will return a tuple of feature matrix and label vectors. Both of them are numpy arrays, and so this is different from what we were doing earlier, where we were getting a bunch object, and that time we did not set this parameter to true. But if you wish to get tuples like this, you should be setting the return underscore x underscore y to true. And you can also examine the shapes of the feature matrix and label vector, and you can see that there are 150 examples in feature matrix with 4 features each, and label vector has 150 labels. Alright, so let's move to the other dataset, which is diabetes dataset, and we can load this diabetes dataset with load underscore diabetes function or class from sklearn.dataset API. So as usual, you can get additional details about this loader by accessing its documentation, and then what I have done here is I have actually left this particular thing as an exercise for you, where I have given the steps about what you should be doing here, right? So here you should write a functionality to load the data set and get a bunch object, and then you need to examine the bunch object, look at the description of the data set, find out the shape of the feature matrix, look at the first 5 examples of the feature matrix, find out the shape of the label matrix, look at the labels of first 5 examples, find out the names of the features, names of the class labels. So these are typical exploration steps about a data set, and what I have done here is I have I have created some sort of an exercise for you to write these one-line codes in these code cells that are also included in this collab. We do the same thing with the loads digit dataset for loading the digit dataset, and you can see that there are a bunch of instructions that I have written for you to follow and work on. So as an exercise, you can experiment with other dataset loaders like wine loader, breast cancer loader, and linear loaders, and examine those dataset. So I have actually solved one of these exercises for you for loading the wine dataset. So you can access the documentation of this by putting the question mark before this class itself, and you will get the documentation. You can see the documentation for the wine dataset here. Yeah, you can see that there are 3 classes. There are total 178 samples. The first class has 59 samples, second one has 71 samples, and the third one has 48 samples. Each sample has 13 features, and its features are real positive numbers. Let us close the help. Then we can actually call the load wine loader and get the bunch object and examine the bunch object, look at the description of the dataset by looking at the SCR attribute of the bunch object, and you can see it is not so nicely formatted, but this is the description of the dataset. It lists down the dataset characteristics. It also lists down the attributes, and also has some kind of a summary statistics and the class information. You can find out the shape of the feature matrix by accessing the feature matrix to data attribute of the bunch object, and then examining the shape of this particular feature matrix. You can see that there are 178 examples, each with 13 features. And we can look at first 5 examples by accessing the feature matrix and its first 5 examples like this. Then there are things like examining the shape of the label matrix, looking at first 5 examples, and so on. And these are the names of the feature. These are 13 features of the dataset. They include alcohol, malic acid, ash, alkalinity of the ash, magnesium, total phenol, flavonoids, and so on. There are these 13 different features in this dataset, and there are 3 classes: class underscore 0, class underscore 1, and class underscore 2 are the names of the classes. So in the same manner, you should explore this breast cancer dataset and linear root dataset. Yeah, that was about loaders. Let's move to fetchers. So we are going to use California housing dataset for demonstrating the feature transformation as well as linear regression concepts, or how to perform linear regression in sklearn library. we are going to use California housing dataset, and we can fetch the California. So California housing dataset doesn't come bundled with a sklearn library. We need to fetch it from the internet, and fortunately we have fetch underscore California underscore housing class that is provided by the sklearn.dataset API. We can look at the documentation by putting the question mark before the name of the class itself. Again, this fetches return bunch object like loaders. We can also make fetches to return tuples by setting return underscore x underscore y to true. And we can fetch the California housing dataset by calling fetch underscore California underscore housing. We get the data in the housing underscore data bunch object, and we can examine this bunch object by looking at the description of the dataset, by checking the shape of the feature matrix, looking at first 5 examples in the feature matrix, looking at the shape of the label matrix. So there are about 20,640 examples, and each example has got 8 features. And we can also see that the label or the label matrix here, in this case there is a single label, single target, hence it's a label vector, and it has got 20,640 examples. So we can check the shape, the first dimension of the target and feature matrix to make sure that the number of examples are same, or the first dimension is same in both the cases. This is the basic sanity check that should be done on each dataset that you load in memory. Then we can look at labels of first 5 examples. You can see that the labels are real numbers in case of housing price dataset or housing dataset. We can also look at names of the features. So there is mid income, house age, average room size, average bedrooms, population, average occupancy, latitude and longitude. These are the features, and then the label is median house value. So that was about California housing dataset. We are also going to use fetch underscore OpenML API in one of our collabs, and mainly to fetch the digit dataset or for loading the MNIST dataset. So fetch underscore OpenML is an experimental API and is likely to change in the future releases. So we can essentially call fetch underscore OpenML with the name of the dataset, which is MNIST underscore 784. We can also specify the version of the dataset here. And here, instead of returning the bunch object, we are interested in the tuple of feature matrix and label vector. So we set return underscore x underscore y to true. And we can examine the shape of the feature matrix as well as label vector. We can see that there are 70,000 examples each in feature matrix and label. And the feature matrix, each example has 784 features. Yeah, so there are a couple of exercises that I have included for you to try. Basically fetch 20 newsgroup as well as KDD Cup dataset. KDD Cup dataset is one of the largest datasets that are available with the fetchers. And 20 newsgroup dataset is a very famous dataset used in the text classification for checking or for training the text classification algorithms. Alright, so that was about loaders and fetchers. Finally, let's look at the generators. And generators basically help us to generate synthetic datasets with specified statistical properties. So there are generators for regression, for classification, single label as well as multi-label classification, and for clustering. So make underscore regression class helps us to generate datasets for regression. So let's generate 100 samples with 5 features for a single label regression problem. So you can do that by calling make underscore regression with n underscore samples, set to 100, this generates 100 samples with features equal to 5, number of targets equal to 1, and we set shuffle to true. And it's important to set the random state, because when we set the random state, we get to see the repeatability in the experiment. And when we run it, we get xy tuple. X is a feature matrix and y is the label vector, and we can examine the shapes of both of these NumPy arrays. So you can see that X has 100 examples, each with 5 attributes, and the label vector also has 100 labels. Let's generate a data set for multi-output regression problem, and let's say we want to generate a data set for multiple regression with 5 outputs. So in this case, we just set n targets to 5 by keeping all other arguments the same. So if we compare these two statements, they differ only in these n targets. Here it is 1, whereas here it is 5. Okay, we can examine the shapes and make sure that the basic sanity check is passed by the loader or by the generator here. In the same manner, we can use make classification functionality from the sklearn dataset API for generating random n-class classification problem. Here we are going to generate a classification problem with 100 training examples, each with 10 features, and number of classes equal to 2. So it's a binary classification problem, and number of clusters per class, we are setting it to 1. So this is a simple classification problem that we are trying to set up, and again we are setting the seed. So here, if you recall, make classification first of all generates clusters and then assigns those clusters of points to the classes. And here we are saying that we want to assign points from a single cluster to one class. So in that sense, it's a simple classification setup that will be generated by this particular statement. We can examine the shapes, look at first few examples and their labels. And if you want to generate a multi-class classification setup, we can simply change number of classes to 3. So earlier this was set to 2 for binary classification setup, but now we want a classification setup with 3 classes. So we simply modify these n classes to 3. And then we perform usual checks on the loaded data. So that was about a single label classification problem with binary and multi-class setups. We can also generate multi-label classification problems with make_multi-label underscore classification functionality. So here again we have to set n samples, n features, n classes. So n classes tells you how many labels are there, and this n underscore labels is something which is new, which was not there earlier in make classification setup. And this n labels provides average number of labels per example. So the average number of labels here is 2, and you can see that the label is no more a vector, but it's a matrix, because we now have a multi-label classification problem where each example can take more than one label. Now let's examine a few rows of feature matrix and label matrix. So feature matrix is similar to what we saw in regression and in the earlier classification setup. But what is interesting is this label matrix. Earlier it used to be a label vector in a single and multi-class classification setting. Now we have a label matrix, and you can see that each example has more than one label. So wherever the label is present, it is represented by 1, and if it is absent, it is represented by 0. So in that case, in the case of the first example, there are 3 labels that are present, label 1, 3 and 4. Then in this fifth example, we have label 2, 4 and 5 that are present. So you can, this is different from the earlier setup. And finally, we have make underscore blobs to generate dataset for clustering. And here we can specify, the number of samples, the number of centers, number of features, and number of centers basically help us to generate dataset from those many clusters. So since we are providing 3 centers, we will be generating dataset such that there are 3 clusters. And you can find the cluster membership of each point through the label vector, and you can see that the first point belongs to cluster 2, second one belongs to cluster 2, third one belongs to cluster 1, and so on. So this was about loaders, fetchers, and generators, the 3 main kinds of APIs or the 3 main kinds of functionalities or interfaces provided by the sklearn.dataset API. Apart from that, there are other functionalities that are provided to load training data in other formats, maybe in libsvm sparse format or in audio, video, as well as image formats. Also, the training dataset could be present in formats like CSVs or in binary formats, mostly in scientific computing. And we looked at functions or interfaces to load that kind of data, and I urge you to try out those those interfaces on your own and get yourself familiarized with how to load training data in different formats with sklearn.dataset interface or sklearn.dataset API. So I hope this gives you a clarity on the theoretical as well as practical aspects of the dataset API, and now you have a good idea of how to load training datasets in memory and perform some of the learning based on the algorithms that you are already familiar with. So in the next video, we will study or we'll discuss dataset preprocessing and something like dataset transformation, feature extraction, feature reduction, etc. So until then, goodbye and namaste.